Hi, and welcome to the last question of the 2018 Paper 1 of the Junior Cert Higher Levels, question 14. As usual, if you want to copy these notes, just send me an email at shanetroy@gmail.com. That email address should be in the description below. So question 14 here has a part A and says use factors to simplify this algebraic expression. Now, before we look at it even deeper, it's using n instead of x. Okay, now if you prefer, you can swap the n for the x if that puts you in more familiar territory. But this top part of the expression is a quadratic equation. And looking at it here actually shows the bottom, okay, but they're just different types. This is, I suppose, we call a full quadratic. And this one you can solve using the difference of two squares. So we have to solve, I can see, the factors of both those quadratics and then see what happens. Now, I've it done out here, okay, so it's fairly full on. So I'm trying to, I suppose, explain what's going on without dropping out too much of the content. So the answer here, okay, is 2n squared plus n minus 15. Now, this makes it a bit trickier because there's a number in front of the n squared. We can handle that, and we end up getting the factors, and I'll go through that, how we get them in a second. 2n plus 6 times 2n minus 5. Generally, you have to see if there's something that will divide evenly into one or both of the factors. Both of them can be divided by 2, so you end up with n plus 3 times 2n minus 5. If I multiply those two-term bracket by two-term bracket, I should end up back where I started. So how do I do that? Okay, so the first step with the method I know, okay, and you may have a different method, and there's many different ways of solving a quadratic. There's always the minus b formula, okay, but there is this faster way. So I'm multiplying the number in front of the n squared, if there is one, okay, by the number at the end, the minus 15. So 2 times minus 15 is minus 30. Now I'm looking for all the factors that will multiply to give minus 30. At the same time, I'm trying to see which of those factors will add to give the number in the middle here, which is basically plus 1. So I've written that down here. Now, I have multiple choices, and I want to see which one of those choices for both those scenarios matches up. So you see here, okay, if all the factors that multiply to give minus 30 will be minus 30 by 1, okay, plus 1, or 30 by minus 1, minus 10 by plus 3, or plus 10 by minus 3, okay, minus 6 by plus 5, or 6 by minus 5. Now there, I can't think of any of your factors offhand that would multiply to give minus 30. Now, what factors, or which of those factors would add to give plus 1? Well, minus 30 plus 1 will never combine to give plus 1. Neither will 30 minus 1. Minus 10 and 3, no. And 10 minus 3, they'll never combine to give 1. But the minus 6 plus 5, when you add them together, you get minus 1. Or it could be the 6 minus 5, which could be plus 1. But I'm looking for, okay, actually I'm looking for the plus 5. So 6 minus 5 gives you plus 1. So these are my two factors. Okay, 6 and minus 5. So I put them in here. Okay, so you put in your first bracket. Now usually just you open up the brackets. Okay, and because it's 2 in the beginning, you put 2n. Now, apologies for the terrible thing, it's hard to do. And then you put your factors 6 and minus 5. And from that point on, we have the text here. You can look at dividing one or both of the factors by a common number, just to simplify it, and we end up with this point here. So this quadratic factorizes to give these two factors. Now the bottom part, okay, I'll get rid of all the stuff. This is the quadratic. Now remember, this is not a quadratic equation, these are quadratic expressions. So I can factorize this with the difference of two squares. Okay, so the method here is you look for the square root of the number at the end here. Now square root of 9 is 3. And we learn off that it's, if in the difference of two squares is going to be n minus the factor and n plus the factor. In this case, the factor is 3, so n minus 3 times n plus 3. That's handy. So I factorize top and bottom, so I'm going to swap them out. Okay, I end up with this expression here. Now, nothing's changed. This is the same expression. It's just showing the factors from the top part and the factors from the bottom part. If you see what's going to happen, something that's common top and bottom is going to cancel. So the n plus 3 here is going to cancel the n plus 3 here. And you're left with what you're left with, okay, which is the 2n plus 1 divided by n minus 3, which I've reflected there. That's it, simplified. So that's part A. Now, part B here is worth 10 marks again. This is the last two parts of the question, and they're marked together. So you're hoping to get one part right to get up to the high partial 7. Now, I find this fairly tricky when I first tackled it, mainly because it's confusing what they're asking, and it actually turns out to be really simple. That's why I put in this thing here. But basically, in maths, it's very common that you have two things that are basically the same and can be swapped in between. So a good example of that might be the perimeter, okay? So maybe the perimeter of something might be a square, it might be 4 times the length, which is x. And you might also be told that p equals 24. Okay, you have to make the leap that well, p and p are equal, therefore 4x equals 24. You can solve that for x equals 6. So that happens again and again and again in maths. So always be watching for it, okay? So in this scenario, okay, if you see here, I'll read out the question part B. For all values of a, b, and x is the number of n. Now that just means for all values of a and b, x is the number of r, sorry, it means it's every single number. You know, positive, negative, fraction, whatever. And they have the statement x plus a times x plus b is equal to x squared plus a plus b times x plus a times b. Now, it's a jumble of stuff and I have no clue what's going on, okay? But it says, using this factor or otherwise, answer the following two questions. So part 1, solve the following equation in x, where a and b are constants, this means they're numbers. Give each answer in terms of a or b. We get a space here for the answers, basically. Okay, so I'm going to flick onto the answer here, but basically, if you cop that this, okay, is this. Once you cop that, you can swap them. Okay, so if you swap them, you then have an expression times expression gives 0. That means that one of these expressions must be 0, because otherwise you wouldn't get 0 as an answer. Or maybe both of them are. So we can say x plus a equals 0 or x plus b equals 0. Solve both mini equations. You get x is equal to minus a or x is equal to minus b. That's where we reflect here. Now it's, to be honest, I'm not even sure if I understand that, okay, but that's the answer, okay. It always seems too easy. That's when I was first tackling it, I was like, it can't be that. It must be something I'm just missing. And then flapped around for a while and then realized, no, it is just that. Okay. So the same thing is happening actually in part 2. It says simplify x squared plus a plus b times x plus ab divided by x plus a. Now again, if you cop that this thing in the square brackets is x plus a times x plus b, so swap them out. And the divider symbol is weird the way they've written it there. Now if I scratch this out, okay, and wrote it like this, okay, it might be more appropriate. I don't like seeing the divider symbol. So this statement here, that's equal to, like nothing's changed here. I've just swapped out the x plus a times x plus b because I was told they're the same. Once you get to that point there, you go simplify, well, something will cancel top and bottom, and you're left with the x plus b. So again, deceptively easy, okay. The divider symbol might end up putting people off, okay. But if you're messing and trying to problem solve, you might write in a way that seems more normal, and that might help you to go, oh, sure, that's just, they're the same. If you think it, why not try write out? And then it might be obvious that these things cancelled. Okay, so that's question 14 finished, okay, and that's the end of the 2018 paper 1. Thanks very much, and best luck in the exam.